So, thank you very much for coming to my talk, Testing Spring Boot Applications Demystified. Within the next 60 to 90 minutes, I want to show you a mix of best practices, pitfalls, and real-world strategies for your Spring Boot application when it comes to automated testing. I want to make this talk a little bit more interactive, so I've prepared a Menti. This is like an anonymous Q&A feedback tool that you can use for free. You can either scan the QR code or visit menti.com and enter the 8-digit code to enter our room. Because also after the talk you will be able to win some prizes if you participate. And to make sure this whole thing works, please answer the first two questions that you should see now in the browser. First question is, despite having LLMs and code agents now at our hands, do you still write your automated tests by hand? Yes or no? And the second question, quite interesting, do you enjoy writing your automated tests? Yes or no? So please answer these two first. There will be more. I will mention it in the talk whenever there's a question. So we can immediately see the answers. So 17 people have answered. Thank you very much. You don't have to join. So 14 people are still writing them by hand. And for 3 people, the AI has yet already taken over. When it comes to do you enjoy writing automated tests, that's really nice to see. So 2/3 of the audience enjoy writing automated tests. So I gave this exact talk the last week at 4 different Java user groups in Swiss, and the results were quite different. So there I had quite some audiences where it was like 99% do not enjoy writing automated tests. So yeah, but still good that you're at my talk, and thank you very much for participating. As part of this Menti, quite late into the talk, there will be 3 text field questions. If you answer them and add your first and last name in brackets, you will take part of a raffle to win one of the 3 prizes. So I've written a book about Spring Boot in AWS that you can get for free. I've written a book on testing, and also you can get a coupon code for my online course. If you want to take part, please add your first and last name when it comes to the free text field questions. And anytime, please raise your hands if you have questions within the talk. I want to get started with how I got into testing quite early in my career. So I studied business information technology in Mannheim. So it's 50% computer science and 50% business information. We learned everything you can learn in computer science. So the ISO-OSI layer model, we learned about UML diagrams, about operating systems, about programming with Java, object orientation, but nobody really taught us how automated testing works as a software engineer. Quite late into our studies, we had one group project where we had to form a group of 4 people and develop a small game. We should use Java Swing to develop a company simulation game, which was round-based. So every round, as a CEO of a company, you could make some decisions, buy a competitor, increase prices, fire people, whatever you can do as a CEO. And as part of this course, one of the requirements was to have automated tests. So how it usually goes, we form the teams, everybody is happy that we can now finally code a cool project. We work on this assignment day and night, and almost one day before we had to submit our final result, we rechecked the requirements to pass this exam, and we forgot about automated tests. So as nobody taught us how it works, we just threw in some dependencies to our project. So JUnit, Mockito, everything was included, but we were calling public methods, we were calling our constructors, we had no assertions, nobody really taught us what to do, so we just did something. Luckily, we still passed this exam or this assignment because I guess the lecturer just wanted to see something in source test Java. So that's not quite a nice introduction for me to automated testing. University ended, and then I started as a new junior developer in a company, and their journey, at least my journey to automated testing, continued. I picked the first task. As a newcomer, you try to prove yourself, you're new in the team. It takes ages until Eclipse is set up, until you can download all the dependencies, until you finally start the project. You're then happy you have something to work on in isolation. I worked on it in isolation, raised the pull request, and the answer from the former lead developer in our team was this. So he rejected my changes because I had no tests. So I rechecked the Jira ticket and I couldn't see any sentence mentioning automated tests. So I learned about definition of done, that it's part of the job to have tests written before submitting the code. When I asked the lead developer and the team, what should I do with automated testing? How should I write my tests? They just said, look at what we're doing at the other tests and try to adapt and figure it out yourself. So quite bumpy road into testing. It continued for some years, and somewhere along the line I decided to really dig deeper in this testing topic and somehow found my niche now as a consultant to teach and consult about automated testing. That's why I'm also here today. So for this talk, I would like to, as I don't know all your current experience with Spring Boot, Java, and testing, I still want to cover the foundation when it comes to automated testing with Spring Boot. I want to give you an introduction to what I think is a really excellent testing support that we have with Spring Boot. As mentioned, a showcase of best practices and pitfalls. And I guess only for 1/3 of you, I still have convinced you that maybe testing is not an afterthought. It can be an enjoyable practice if you know how to do it. Some words about myself. So I'm Philipp, a self-employed IT consultant. I'm from Herzogenaurach, that's 200 kilometers north, close to Erlangen-Nürnberg. We have two major firm headquarters, Adidas and Puma. Maybe some of you know. Besides consulting, I'm blogging and creating content in this sphere about automated testing for some years now. And founder of a company where we try to help clients deliver software with more confidence and more frequently. For the agenda, we just finished the introduction. I want to follow up with the rationale, why do we test software? The main part of this talk will be testing Spring Boot applications. We will start with the foundation, take a look at unit testing, slice testing, integration testing, and end-to-end testing. And as mentioned, as part of the final chapters, we will take a look at best practices and pitfalls. So why do we test software? Hopefully not to make our management happy, so that they have dashboards where they can render the code coverage something to 80% and above. If you ask this question to developers, they will answer differently depending on how they see testing. For me, if it's one word, it's confidence. And some month ago, I tried to formulate my subjective view of confidence in a project. So when I go to clients, that we have an aligned North Star. And the idea I try to shoot for, so for sure it's quite extreme, but with all the testing efforts and all the automation efforts, I try to follow this North Star. So imagine on a Friday afternoon, you get an email that Renovate or Dependabot raised a pull request. In this example, we will all have this in November or December, I guess, to a major Spring Boot version. Your pipeline is green, so somehow your automated tests and all your test suite reports that we can bump. There is no issue with compiling, so for sure that's not how it will look like, because there will be compilation issues, but imagine something larger to be integrated on a Friday afternoon. How confident are you to press squash and merge and deploy this change to production? So for me, testing is not just catching bugs, it's somehow the confidence we get in making code changes and integrating library updates. And apart from automated testing, so for this North Star, you also need way more things. You need automation, you need fast build times, you maybe need feature toggles to decouple deployment from releasing a feature. But overall, that's at least the North Star, or if someone asks me why do we need to test software, for me it's confidence, and this can be an achievable North Star that you want to aim for. For sure, your team might look different, you might have fixed release cadence or a more extreme project, but maybe there's something you can take away. For the basics, when you work with Maven as a build tool of choice, when working with tests, we have basically two options. We have the Maven Surefire plugin. The Maven Surefire plugin selects or is designed to run unit tests. It finds a unit test by the postfix. By default, that's the word test. If you put this behind your test class name, JUnit, Maven Surefire will collect this and run your test. When will it run the test? So on the right side, you can see the Maven build lifecycle parts of it. JUnit will run the blue bar here after test compile. So after your tests have been compiled, JUnit will run your unit tests. Next plugin we have and can use out of conventions is the Maven failsafe plugin. This is designed to run integration tests. It detects them by the postfix IT. So you can also customize this, change this, but this is the default. So for example, a test named checkout IT would be detected as an integration test, and failsafe will collect them and pass them over to your test framework of choice. The integration tests are run a bit later into the build lifecycle, so there is a dedicated integration test phase where the tests will be executed, and failsafe also needs to run its verify goal to collect the test results. So if you forget to run the goal verify here, if your integration test fails, your build will still succeed. So if you run Maven verify, it will run by default if you configure the correct goals as mentioned in the failsafe documentation. You might wonder why to split it. So technically you can also use the Surefire plugin to run your entire test suite. That's possible. There is no harm done to anything. There are some reasons. One of the biggest reason can be to fail fast. So if we run our, generally speaking, fast unit tests before our integration test, and we have a unit test failure, we get much more early the result instead of waiting maybe for 30 minutes for the entire test suite to run. So the build will then stop and you can immediately fix it. That's a potential reason for splitting it up. Another reason is if we want to optimize for build time, so this will be also a big topic of this talk today. We want to have fast feedback with fast build times, meaning fast test executions. You can configure the parallelization differently if you split it. So unit tests are usually quite easy to parallelize, whereas integration tests are a bit more harder to parallelize. So by splitting them, you can tweak those configurations separately and can step by step start with unit tests and then move on to integration tests. And for sure, organizational wise, it also helps to understand, maybe also for junior developers, am I currently writing a unit test or an integration test, to have a little bit more structure and understanding in the organization of your tests. If you use Gradle, things look a bit different. Unit tests are run with the default test task. If you want to separate unit and integration tests, there is no default option within Gradle. You would have to register your own integration test task, configure it how it detects the integration test, and plug it somewhere, usually after the tests, to your build cycle. It's possible, as in general with Gradle, you have a little bit more fine-grained choices in your build.gradle, whereas Maven is more a conventional build tool. Next one, I would like to talk about something that all of your Spring Boot projects get out of the box, which I refer to as the testing Swiss Army knife. So when you start a new Spring Boot project, for example at start.spring.io, and you select your dependencies, your JDBC driver, your web dependency, Timeleaf, and generate it and open your POM, you will recognize a test dependency that you did not actively select. So Spring Boot the Spring Boot team made the convenient choice to include this to all Spring Boot projects, so that you have really a testing Swiss Army knife. You have batteries included when it comes to testing from day one. So with this single Spring Boot starter test, you will get a set of transitive dependencies that are pulled to your project, and from day one you can get started. So there is no need to have an architectural guild decide whether to use JUnit or TestNG. You don't have to configure anything in your build tool. Everything is there, configured to be used from day one, which makes it quite convenient. So let's take a quick look at what you get with this foundation. So when you run Maven dependency tree and analyze all the transitively pulled dependencies, you can understand what dependencies you get. So we have JSON path, SRJ, avatility, Hemcrest, and much more. We will see in the next slide with one sentence what they all do. But the cool thing here is, like with everything that Spring Boot manages for us, Spring Boot manages also the dependency version for us, so we can really go off hands. We can get out of the driver's seat. We don't have to care about managing the version of SRJ, making sure JUnit aligns with the Maven plugin, and the extension works with Spring Test. So it's really hands off, and cool that someone takes care of it. Whenever we bump Spring Boot internally, we will bump some of these dependencies. For sure, we can at any time opt out. So we can also say, for whatever reasons, I'm on Spring Boot 2, but I need the recent Mockito. I can manually override the version. So Spring Boot agrees to pick our overruled version. So the standard Spring Boot dependency management also applies to testing, which is super convenient. Sure.
Do you maybe know why they decided to include both SRJ and Hemcrest? I mean, I know that some people use one, some people use the other library, but
that's good.
If you're both at the same time.
Good question. So some of the Spring Test, mock MVC, for example, has methods that accept Hemcrest matchers. Maybe it's a traditional thing. I can only think of that they started with Hemcrest and allowed some methods to take a Hemcrest matcher, and now it's part of the Spring Test API, and now you have to live with your tech debt. Yeah, that's how I could imagine. So quickly, if some of these are new to you, in one sentence what they are doing. JUnit, currently we have version 5. Version 6 is already released in September and will come with Spring Framework 7, respectively Spring Boot 4. JUnit is Java's de facto standard testing framework and the foundation of our testing suite. We get Mockito. Mockito, we can love or hate it. It's for mocking objects and quite convenient for both unit and integration testing, which we will see. SRJ. JUnit comes with assertion, the classic assert equals. SRJ has it a bit more nicely. These are fluent and chainable assertions. So it's the assert that is equal to. They also offer assertions for common Java types like Java time and collection. So it's a bit more readable and friendly to the developer. We have Hemcrest, yet another assertion or matcher library that is used, that is part of this box. JSON assert, when you compare entire JSON strings with each other, you can use JSON assert. JSON path, so this is not a testing library rather than a utility. It's like XPath for XML, but for JSON. So you can define with a query language, we will see it when using mock MVC, to extract parts of a JSON, like you have a deeply nested JSON and you're interested in the final object for a specific value, then you can use JSON path to extract this value and write assertions. XML unit, assertion library for XML. Awaitility, that's quite new. That was added to the Spring Boot starter test. That's quite convenient library when you work with async code. So imagine a message queue that listens to a queue, reads a message and stores something in a database. If you would write a test for this and immediately write assert equals after putting the message into the queue, your test most likely will fail most of the time, because like from putting it into the queue to reading it, some time happens in between and it's async. So developers tend to then use thread.sleep in your tests, which is possible, but if you do this more often in your tests, your build time will increase. Awaitility fixes this. It's like a fluent, chainable assertion library, similar to SRJ, where you can declare, I'm waiting at least 3 seconds for this state to happen, for the thing to be present in a database, and all the async handling stuff, polling, checking is handled in the library. So also this is part of Spring Boot starter test. Unit testing. So unit testing in short, there's not enough time to go to unit testing in details, but with unit testing in general, the core concept, we want to test an individual component, rather either a class or a method in isolation, and usually mock the dependencies of this class, because we want to focus on the method at hand. The confidence we gain is usually quite good if it's a small method, easy to test, some logarithmic, mathematic things, business logic that we want to verify. As a best practice, we should focus on a single unit of work. The pitfalls, I guess we have all seen these big God classes, so classes that grow inside with many dependencies, where it becomes super hard to write meaningful unit tests. So for efficient unit testing and unit testing that makes fun or is enjoyable, the class design really has to be thought through. Otherwise, it can end up that you almost re-implement your implementation in your tests, and there is nothing gained. The tools we use, usually a testing framework. With Spring, it's JUnit. You can still opt out and say we are using, I don't know, Spock or TestNG, but then you have to take a little bit more efforts in configuring everything and maintaining the versions. Mockito is used, an assertion library of choice. So you have now seen 3 assertion libraries. JUnit has assertions, SRJ and Hamcrest, which one to pick. So there is no right or wrong. I usually tend to stick to SRJ, and if someone asks, I at least advise stick to one in your project and at least in one test, because if you mix assertion libraries in the same test, it can end up in a mess, because like the way the expected value and the actual value are passed between these assertion libraries is different, and then it's not so nicely readable. But unit testing has limits. So unit testing is nice for small methods, algorithmic, logarithmic things. But if we take a look at a classic REST controller, so nothing complex here, it's a post mapping HTTP post. We want to create a customer. We pass a customer which is validated with bean validation. This is happening, and we delegate the creation to a service. So service gets injected with the public constructor, dependency injection, all the good things. And after creating the customer, we are returning a 2 or 1, following RESTful best practices, and return a header location where the clients could refetch the freshly created entity. So now the question, if we write a classic unit test with only the tools we just saw on the previous slide at hand, we would end up at a place that somehow looks like this. So I know that's quite now fast rushing through the implementation, but I hope at least most of you have written a unit test with Mockito before. We are using the Mockito extension to simply create our mocks. So we only have to use @mock on the customer service. In the background, Mockito creates the mock. We tell Mockito, please instantiate our class under test, which is the customer controller, and inject the mock. And now when we have our test, what can we do? So with our test, we are calling a public method. We pass the entity, the record that during runtime a JSON is serialized, but here we pass it directly. And that's the first point where it feels a bit weird. So it feels like a bit brute force. So during runtime, there is a lot of stuff going on. So there is security, there is checksums, serializing and deserializing. With a unit test, we now blindly pass an instance of the Java class. We would lose any bean validation checks. So here you see I'm passing over an email. Here we can pass any string. So you could somehow prepare a request here that is not valid. So that's, yeah, feeling kind of weird. We can test the HTTP status code. That's possible. We can test some headers as we're returning the Spring response entity. There's something to verify. But still, we would also lack security. We directly invoke the public method. During runtime, someone protects it. That should be also tested. So there are some parts that we couldn't cover that well, or at least the confidence we gain is not that great. Imagine we have a get endpoint that returns a list of objects that are serialized. With a unit test, we have a list of Java objects at hand. We couldn't verify that there is no change in the API contract. We can't check if our path mapping working. Imagine a more complex path mapping where query parameters are resolved. All of this is with unit testing impossible. So unit testing has its benefits, but there are some places in our application where unit testing doesn't bring us the desired benefit. And that's where slice testing comes into place. So that would be the next topic to cover. With slice testing, we have a better alternative for testing for specific parts of our application. To understand how slice testing works, let's step back and take a quick look at how a typical application context can look like. So the application context, like the entity that holds all our Spring beans during runtime, usually consists of different bean types. So we have a web layer, so these are all our controllers, the filters, the interceptors, so everything that is related to the web is somehow usually a singleton inside this entire context. We have a service layer where we perform business logic operations, and some utility classes, some HTTP clients, so various kinds, and down beneath, for most of the applications, a persistence layer or repositories, the data source, So that's how it looks like. Spring Boot came up with a nice idea that we can slice our application context. So we can create dedicated slices for this application or for our application context, and during testing only populate a minimal subset of beans inside a context. So not everything, but just carefully selected parts of our application context that we can test in isolation. Here's just a few of them. So we have @webMVC test that we will take a closer look at to test our web layer. We have tons of annotations for the persistence layer. We have something to test HTTP clients. There is no slice for the service layer. Usually unit testing is good enough here, so everything in between, the service, business logic, utility classes, they can be carefully tested with unit tests, but everything on the outsides, so like anything that enters our application or at the bottom connects to persistence or REST clients, for these parts, Spring Boot came up with a nice way to test it in isolation. If we take a closer look at WebMVC test, so taking WebMVC test now as an example, and we want to slice it, and we want to test we want to write meaningful tests for our controller, then we not only need our controller inside this context, we need everything related to web. What is related to web? Servlet filters. If we have implemented servlet filters, it would be great if Spring could put them also in the slice context. Converters, add controller advice, our security configuration, that would be super nice if it would also be part of the slice context. filter, interceptor, JSON component. There are many different beans that are relevant. The Jackson object mapper, all of this is somehow relevant when testing the web layer. We are not interested in any repository. So when we test or want to test the controller in isolation, like checking path mapping, validation, security, serialization, deserialization, we don't care how the data is persistent. We don't care if there's MongoDB, if there's a Kafka, if we connect over HTTP to SAP. Nobody cares. And we only care about a meaningful subset from web Spring types. We will see our web layer usually has a dependency to a layer below, to a service. We have to provide this service into the context, because what Spring will do, it will do component scanning with a filter. It won't do the entire component scanning and build the entire big context, but only filter out the beans that are relevant. So for the service, it won't configure it, and we will have to provide this bean inside our context. Otherwise, the context won't start. Let's see this in action so you better understand what I'm referring to. So let's navigate to the mentioned controller. So just for you to see, I have not changed anything from the slides. I have prepared a meaningful slice test now. You can see the web MVC test annotation, and the magic usually is inside it. It's a meta annotation with quite some annotations. So if you're new to Spring Boot, you might think, what the hell is going on here? First have to understand all of these annotations. So for sure, to understand how slice testing works, it's quite important to understand like Spring's auto configuration, component scanning, and many of these basic concepts. But the important thing here is line 104, the web MVC type exclude filter. If we take a look at this one, we will see the single point of truth of all the bean types that Spring will look out for in the component scanning and include inside our minimal application context. So it will scan our application, and if you are of type handler interceptor, I will put you into my basket. You get a part in the context. If you are a filter, if you are a controller JSON component, if you are a controller advice, and much more. So this is like the shopping list that Spring takes, looks inside our application, and then populates a minimal application context for only the relevant web components. So that's the annotation. It comes in two variants. I can use it without a controller, then Spring will scan for all controllers. Or I can specifically mention one controller. It can also be a time-leaf view controller, so it doesn't only apply to REST APIs. Also works here. I pass now this controller, so we have a single controller within. Let me quickly remove this annotation and show you a failing test. So what this will now do, you saw the Spring Boot logo. So whenever you see Spring here, we are past classic unit testing. We are somehow now testing with an application context, either a full or a minimal. If we scroll down to this big stack trace, we can see what we were expecting. Our customer controller required a customer service to be present in the context. Spring doesn't have @service classes on the shopping list when it scans for the components in the context. So the context won't start because our application controller here has a hard dependency on the service and it can't find it in the context. So the test fails, context won't start. We have two ways to fix this. We can either instantiate the real customer service and put it ourselves, like importing it, but then we would also make sure its dependencies, then what do we do with the customer service? So this question then traverses down the tree until we find a point where we, again, start everything. So the idea is to mock usually at the layer below and really only care about the web layer. And one way to do it is using Mockito Bean. If you're not on a recent Spring version, you might still use mock bean, but mockbean is like deprecated. That's why don't worry what I'm using for annotations here. This is like the successor of mockbean is Mockito Bean, and this will put a mocked version inside this minimal context. So now, if this is inside, dependency injection should be happy because now all beans are there. If we would have now complex filters or interceptors that also require a service or repository for whatever reasons, we would also have to provide these in the context or provide a fake implementation. So this problem propagates to everything, but usually we are good to go. What we now get out of the box is, you see, I inject here something into my test class. This is mock MVC. We don't want to invoke the public method of our controller that somehow brute force doesn't bring that much confidence. What we get is a mocked servlet environment, and this mock MVC is auto-configured by Spring Boot, contains our controller, all the web configuration, and mock MVC is like an environment and client at the same time. So we can use it to interact now with our controller. And the way we interact with this, you can see down in this test. This almost looks like making an HTTP client to a REST API. So we say post, this is our endpoint. We specify the content type, some nice Java, here template string. We can provide JSON that should be serialized, and then we can write assertions. And here, Ivan, there's one example. Mock MVC takes a ham crest matcher as an overloaded part of its API. So that's why, it's part of it. So what we are doing here now, if you're new to this, you might wonder, is there HTTP communication happening? No. So there is no port occupied. We are within this mock MVC environment, which is like in-memory servlet containerish. So it's not a Tomcat, it's not a Jetty, it's in-memory mocked environment that you interact with, but you follow HTTP semantics and can send data and act with it like an HTTP client. So for example, if we remove here the email, and just that you trust me, we have here an @validated request body, and I have here bean validation, email must be email. So if we do this and run the test, we should see 400, and we see 400. So our assertions were false. The cool thing is that I wanted to show you, this also prints some nice debug analysis information if the test fails. So you interact with mock MVC with a mock HTTP servlet, response and request, and you can see error message, you can see the headers, the content type. If data would be returned, our 201 returns no data, so nothing to be seen here, but much more. If you would test Thymeleaf views, you can see the view name here, the model, so that's also quite convenient to write tests against the model, the rendered view, super nice. You can see the resolved exception and also our request. So this was our request. We had implicitly the content length header that was added out of the box and our payload. So we can now test at various places multiple things. So for sure, you might wonder, should we now test all the possible bean validation outputs? For sure not. So you wouldn't now test what if first name is present and email is not present, but you can at least, or what I usually do, have one test if there is meaningful, so ISBN checks, IBAN checks, that at least the bean validation is happening and the controller properly validates the user input. So that's beneficial to have one test. You can ensure that your API contract stays the same. So I don't know, you configure the wrong Jackson property, that happens. Or I've seen projects where they had like 10 object mappers in the context, all configured differently, and then you end up wondering, wait, what is actually used for my controller? Then you can make sure such issues don't happen. For sure, a monkey that will hit your keyboard and that won't happen because we have pull requests for sure, but still you have out of the box some confidence that you get with this test that your API is in place. If you resolve any query parameters, for sure things get complicated. You have this in place, the thing stays the same. You don't want to test for sure the framework, so you don't want to make sure that Spring does its job, but still it's beneficial at some places to have this validation. And the really cool thing comes with security now. So I've included Spring Security as a bean inside this minimal context, just for new simple configuration. If you want to post a user, you need to be authenticated and have the role user. So that's our guard that is in front of our API. To test this now, you only need a new dependency, Spring Security Test. This nicely aligns or integrates with Spring Boot and Spring Test. And if I remove everything I did before, like if we would nakedly arrive at our endpoint without any authentication, we would now expect a gatekeeper, exactly, 401. And that's what we get. So for sure, a user, so someone anonymously arriving is not allowed. With this dependency that we added, we now have two choices we can use with mock user. This is from Spring Security Test. We can adjust the user here. We can give the user different roles, passwords, capabilities, whatever. What Spring Security will do behind the scenes, it will put authenticated user inside thread local, inside the security context. So it will place it like also a bit brute force inside the security context. So our controller says, someone is already authenticated. You are allowed to pass through our controller. That's the annotation that we can use and bypass or state the way we are arriving. So we can now test various authentication and authorization ways. A more fine-grained solution is a security post processor. So we can put like the user inside the request with the security post processor and can here define how the user looks like, how the user is named. There are multiple ways. I mean, if we have JWT and, for example, in the controller, fetch use a claim for the roles or inject a claim because it contains our user ID, then we can also provide here a JWT and tweak it to our needs. So there are multiple ways to override it. You can provide CSRF, you have HTTP basic and much more to, I guess we have OAuth 2 login. So all of the different authentication methods that you can use to attach to your request for testing your controller and can now test the various authentication and authorization rules. Again, you don't want to test the framework, but still, I mean, if you have done like Spring Security migrations and migrated from A to B, it's quite beneficial if you have some of these tests, at least happy path and bad path testing for your controllers, that you are sure and you don't have to use Postman an entire night to check, are we still protected or not? Yeah, even more important if you're like public facing, if you deploy to public cloud, that's at least, I mean, this test takes only some milliseconds. You edit and make sure unauthenticated users are blocked, and then you can proceed. So that's mock MVC in like 5 minutes with a quick example. Brings much more confidence. We can test the status, we can test the headers, we have serialization, deserialization, path mapping, security. All of this comes now for free out of the box. There are more test slices. So WebMVC is usually the easiest one to grasp and to understand. If you are using WebFlux or if you're using GraphQL, there are also test slice annotations available out of the box. For the persistence layer, it's the same. So when we want to test, for example, our persistence, we don't care about controller. We care about the data source, transaction management, the entity manager if you use JPA. And Spring will also give us a minimal context for just these bean types. So there's data JPA test, JDBC test. If you use Juke, there's Juke test, and MongoDB, much more. JSON test. If you have complex Jackson serialization rules, you can also test this in isolation. And also HTTP client testing with REST client tests, super handy. There are more. This is just also some of those that are part of the documentation. So check Spring Boot docs, they are usually quite nicely explained. When using them, it's important to understand what gets configured in the context. So you have to understand what is like the basket that Spring scans for and what do I need to provide myself. When you test persistence, you somehow need to provide the persistence itself, so yeah, the database. You can even write your own, so nobody stops you from writing your own. If you have a more complex or in-house, I don't know, persistence thingy or thing you want to test in isolation, or Kafka. I guess for Kafka there's still not yet a slice test. You can write it your own, and usually I point developers to @SQS test. So SQS is like AWS messaging queue. Spring Cloud AWS added a slice test in their library, so you can check how a library implements, or you can also check Spring Boot source code for sure. But this is usually a little bit easier because then you understand how they integrate and what they need to provide this minimal context. So slice testing, next step, and now integration testing. Now we want to test against the entire application context. We saw slice testing is nice at the corners or at the borders of our application, brings a minimal application context and some nice ways to test. Next step would be we want the entire context to start. This test should seem familiar to most of you. So Spring Boot, apart from adding this testing Swiss Army knife to our project, also adds the first test to our project. This looks like this. It has one annotation at Spring Boot test, one empty test that explains what it does, context loads. So if your project is small, this test usually succeeds, but the more complex your application gets, and the more things you're dependent on, the test starts to fail. Because with @Spring Boot test, we will now start the entire application context. And when we start the entire application context, we have to satisfy all the dependencies of our beans. Meaning, we have a persistence layer. Our persistence layer somehow needs access to a database. So this has to be present when starting the context. We may have message queues that our listeners connect to. So we need these listeners or these queues, this infrastructure to be present. We may do HTTP communication to the team next door. So if we follow microservice patterns and we do synchronous HTTP communication during runtime, we somehow have to solve also this for integration tests. And if we fetch things from the internet, I don't know, from SAP, from Salesforce, also somehow this dependency has to be satisfied. So it gets now way more complex than just testing something in isolation. Unit testing, simple. Slice testing, a bit more complex. But now with integration testing, everything has to be available. Otherwise, our context won't start. So the concept we want to follow is that we now start the entire application context, usually on a local random port. That if we have a REST API, for sure there are applications that perform batch operations that don't have a REST API. But I'm like talking about the 80%, I would say, of the applications. We want to start it and want to access it like from the outside as an entity, entire box. The confidence we gain is that we validate now the integration of everything that is working together. We are using @Spring Boot test now, no longer any slice testing. Pitfalls, unit testing super fast, slice testing also reasonable timing usually, but now things get more complicated. Starting the entire context takes time, so I guess 20 to 40 seconds is for medium-sized applications the usual time a context needs to start. And if every context would need this, it would linearly add time to our build, which we want to avoid. So we somehow also have to solve this timing issue. So to summarize it, there are like 3 problems, or three main problems. There are way more that we have when starting the entire application context. First is how we provide the surrounding infrastructure, so databases, queues, file system, I don't know, a key cloak as an authentication provider. How do we make this available? Problem number two, how to handle HTTP communication. So during our integration test, in general, we want to avoid to fetch real data from the internet because this is flaky. We would run into quotas. It would cost money depending on which API we are calling. And the last problem is how do we keep our build time at a reasonable duration to still have fun running our integration tests and grab a coffee. This would bring me to the next question in the Menti. If you could quickly answer, or you already did, perfect. Do you use test containers in your Spring Boot projects? Because this would be, for me, important to understand how much base knowledge we would have to quickly cover. Okay, thank you very much. So 11 person, yes, 1 plans to use it and 4 not yet. So I would quickly go over this slide. So test containers solves problem number 1. So test containers is a library that allows us to run Docker containers for our integration test as ephemeral local containers. So if we depend on Postgres, we don't need to tell all our team members, please install test containers on your machine with this version and then make sure to follow this setup script and clean it up this way. This is inconvenient. Nobody can do this. The idea is to have local containers. Test containers uses internally the Docker Java API to manage the containers. So it takes care to pull the image if the Docker image was not present, to start it, and then only allow the test to run once a health check passes. So it's not just starting a database, we also have to make sure the application can connect. So it's not just fire and forget. So there are a lot of mandatory things the test containers does for us to start a local infrastructure. And a basic example of how to use it in Java code is like this. You specify PostgreSQL container. So Postgres also comes with modules, which provides convenient methods on top of these generic containers. So if we would have a generic container, we would have to specify the correct environment variables. For Postgres, we would have to know which port to map. And these modules, you can find them in the test containers documentation, have wrapper methods. So for example, the PostgreSQL container has a method to get the JDBC URL or to conveniently specify database name, username, without us knowing what was the exact environment variable to configure in this version. So it's a wrapper for us. That's super small down there, but just for you that you've seen it, when you start a container, you will also get a friend. This is a sidecar container, Riecks. So if you're wondering why you get 2 containers, the second container is like a resource reaper that takes care to clean up things. So if the JVM shuts down after your tests, this ensures to clean up the container, to remove, I don't know, networking changes, volumes, whatever you configured. So it's like a sidecar, so to say. And the cool thing is we start usually everything on an ephemeral port, so something 32,000, so there are no port clashes, and we can then ask Docker via test containers, what's the mapped port for the test containers port, and then configure this as a JDBC URL for our application. There are many ways to do it. We can reuse containers with test containers. The simplest way is test containers comes with an annotation. At test containers, we specify this as a container with @service connection. That's a quite new annotation. In the background, automatically and magically, Spring Boot will configure the JDBC URL for us. That's really just in those 2-3 minutes I have to showcase you test containers. But this is really how it boils down. You can apply the same to Kafka, a MongoDB. So everything you can containerize, you can manage with test containers and use it for your integration test to have all your surrounding infrastructure ready when you need it, and also being shut down, working on CI server. Nobody can claim it works on my machine, because with test containers and Docker, it should work on everyone's Sure.
In a past project, I had to argue with ops teams because pipelines were run in Docker containers, and then you have to Docker inside Docker inception. And they were kind of stubborn and didn't understand the point behind this. But do you have any experience running test containers within already containerized pipelines? Does this generally work, or is this something like that's kind of problematic?
So Docker in Docker should work. I'm not 100% sure, but I guess also GitHub Actions. The way you do it with GitHub Actions, like their CI/CD for free on GitHub, is also containerized. I mean, this is GitHub. They have a bit more engineering power, but usually the ops have the doubt with the root access. I thought you were going to the root access that with Docker on a CI server, you have to give root access to the agents. I mean, I can't go into their detailed argumentation, but usually it's like, look, it's publicly available, so somehow it must be achievable. But Docker in Docker and mounting like the Docker engine through your already running container should be possible, yeah.
I think there was some argument like, why do you need Docker specifically? Can't you use Podman? And I said, no, not really.
Yeah, I mean, you also have these like engines with Podman. On my Mac, I use Orb Stack. So I guess with Docker desktop, at least, there is this licensing hell that happened some years ago. So I'm not sure, I can't advise like a company on what tool to use, but you somehow need a Docker engine via Podman, via Orb Stack, Docker desktop, yeah.
I think there was one called Rancher, R-A-N-C-H-E-R.
Rancher.
Yes.
Rancher, yeah.
And it's worked for our case.
Okay. Yeah, I guess the market is like quite diverse there. You have many options. Cool question, thank you. Next problem, what do we do with external HTTP calls? So, like calling them, like imagine an integration test. We are a library application, and when adding a new book to our shelf, an admin creates a new book, they only enter the ISBN. And with an HTTP client, we fetch from the open library, a public API, the title and the authors. So that's like a usual case. We have synchronous HTTP communication. What do we do during integration test? We could call the actual API, but it's not reliable. I mean, we don't want our build to fail if they currently have like maintenance window and then our release didn't went through and we miss a timeline, whatever. Though it's also not predictable if we want to test corner cases, like we want to test a fallback scenario where the API now responds slowly or with a 500. That's hard to call them and tell them, now please for the next seconds return 500, impossible. So the idea is to use a local mock server. One of the main choices or the common choice is WireMock with Java. There are many other. And the benefit is you now run a local web server and instruct it on how it should behave when this request, please give me all the metadata about this book. You can from the outside say respond with this JSON. So you really have everything at hand to respond to this request. And what you then usually do during your integration test, you overwrite the HTTP client's base URL, which you should make configurable from the outside, to point to localhost something ephemeral instead of the internet.
Thank you, I must leave.
No worries. Have a great day.
I will look under the video. Thank you.
So what we can do with WireMock, we can run WireMock in memory or in a Docker container. It's a Jetty server. It's super fast, so I usually run it in memory. It also comes with a JUnit extension, super easy. I only want to quickly show you the two main magic points that you have to make. So you have to override, let's imagine we have a HTTP client that configures this open library client, the base URL. And for our tests, you can then use test property values as from Spring Boot or Spring Test. You can simply apply when the context starts. You can apply the URL because the WireMock server also starts on an ephemeral port. It's like 32,000 something. You need to be dynamic. You can also hard code this, but then if you reuse it, like many other questions, so make it dynamic and then override it. And then it somehow reads like Mockito for objects, but it's for like HTTP responses. You tell the server, hey, I want to prepare a stubbing. When someone reaches myself at this path, API/books with this ISBN, I will instruct you to behave like this. You return a response, by default 200. You return JSON, and you can find the actual JSON on the class path at a source test resources folder with this name. So this will then return this JSON and fake the server. We can put in here, please delay for 5 seconds, please return 500. We can also model stateful cases where we say, please return 2 times 500 and then 200. If we have like retry mechanisms we want to verify, we can simulate slow responses and everything else. So this for sure requires, depending on how many clients we have, to have these JSON present. So either monitor and log during development. When you implement, you anyhow check the API docs of the provider you integrate, copy over some of the examples, have a successful and an unsuccessful case, and yeah, prepare these things. For sure it takes effort and it's not like immediately there, but yeah, brings you really the entire flow of testing with HTTP clients and override them during integration test. Cool. This at Spring Boot test, quickly so that you've seen it, comes in 2 modes. The one you've seen before, this one actually at Spring Boot test, without anything, won't start Tomcat. So if you use a servlet container, to make Tomcat start so that you get the entire application context and your servlet container on a real port, you need to override web environment, either defined port, but defined port would put it on 8080, which has the pitfall. If you start 2 of these, like the second one will crash because port can only be occupied once. With random port, like everything else we just saw, is like ephemeral, something somewhere, but for sure for free or a freely occupiable port will be started. We can then, if we want in our test, integration test, inject it, but we can also use pre-configured HTTP test clients. So the web test client is the WebFlux variant. There's the test REST template. If you work with the REST template, they get auto-configured and already point with their base URL to our random port. So nothing for us to override. And then we can really from the outside, now happens real HTTP communication, interact with our endpoint and yeah, test whatever we want to test as a whole. The downside, or the thing that where it also now gets tricky, is like when it comes to security, we now have to provide real security as authorization header, because we can't do the trick anymore with mock user, because the test does not run in the same thread as the application context. So this like statically hard-coded way of overwriting the security context won't work here, as it really arrives like a client from the outside with HTTP. And yeah, depending on our security setup, this takes a bit of setup work, but yeah, it's doable. I mean, I guess most of us are resource servers where JWT arrives and we have to check the signature. So yeah, we either provide, for example, Keycloak as a Docker container, or theoretically stop the entire HTTP communication that happens. So there are many ways to do it. This Hello World example just assumes basic auth with a single user. I mean, if we manage the users inside our application, that's doable, but otherwise, yeah, takes more effort. The alternative is to not specify anything, and then we get the entire context, but no web environment. What you then usually do, you use auto-configure mock MVC, and now I have like a hybrid solution out of slice testing and integration testing. You have now mock MVC and the entire application context. So it's like a different version to what we had with web MVC test, where we only had minimal context. Now we have mock MVC and can again do those mock MVC user tricky There is no port, so that's why it's commented here. Nothing happens on the port. You still use mock MVC, and yeah, might wonder which version should I pick. I mean, obviously with mock MVC still there's something mocked, so we are not that close to production that we could be. So in general, I favor to have at least some happy path tests with this. So no mocked servlet environment, nothing mocked. I want the real thing to be started. And if there's any reason to that we can't do the other test, this is a good example. But the benefit you gain is like you now test like your slice test, but with the entire background operation. So your service now does its job, and you need database. So there are still some benefits to test everything as a whole, but in a mocked environment. Now, tackling the last problem, and I would say one of the most important or the coolest hidden gems of Spring Test, the context caching. So this would be also the next question in Menti. If you are aware of it, it would be super nice for me to understand. Coming back to the problem we have, if we now start many of these application contexts, in the worst scenario, every integration test starts their own context. We add up like 20 to 40 seconds for each integration test class run. That's like linearly adding build time to our project, which is in the beginning quite okay. So as long as you're below 10 minutes, it's fine. But once projects grow in size and complexity, you somehow end up between, I don't know, 30 to 40 minutes build times, and developers become unhappy, then flaky tests come in, and then, yeah, the whole things goes down. So Spring has a solution for it. It's the Spring Test Context Framework Caching. It caches an already started application context for your integration tests for later reuse. That's super smart. By default, all of your Spring Boot projects have this feature enabled. You might not be aware that you're using it behind the scenes. And as an example, this was one client where we optimized for it. We had a build time from 26 minutes, and solely by focusing on this feature that I'm about to show you, we went down to 12 minutes, and we did not even start parallelizing the tests. So more than 50% time improvement for a build, which is quite nice, and we only had to focus on how we structure and write our integration tests. So how does this work? In the end, it's a cache. So imagine a use case. We have an order IT, the first test that runs inside our project. This requires an application context configuration. It's the first one. Our cache is empty. Hence, Spring will start a context. The test will run and put the context into the cache. Next, the payment IT runs. It requires the same context. There will be a quick lookup inside my cache. Is there something in my cache? Oh yes, I have something. Immediately hand over the context. Payment IT runs super fast, puts it back to the context, to the cache. Fulfillment IT, the third one, requires a different configuration where we get a cache miss, nothing in the cache for us. You get a new cache, and the context will be put into the cache afterwards. So when working with a cache, we want to optimize for cache hits so that we can reuse stuff. And to understand how we can reuse, we have to understand how the cache key is built, because this determines if you get context or not. On top, you can see really framework code, default context cache. The cache is implemented with a simple map, like you would imagine in Java. The key is merged context configuration, and the value is application context. We get a map of size 32. This is configurable. You can override it. By default, it's a least recently used cache. So if the context 33 arrives, a cache will be evicted that was least recently used. So it's like evicting by this strategy, but we can configure the size. You can increase, decrease, like everything with Spring Boot, there is a property. So the important part is, how is this merged context configuration built? So this context configuration really needs to uniquely identify the context configuration that an integration test requires. Because Spring, when reusing a context, cannot make a mistake. It cannot give a class a context that doesn't fit the required context configuration. That's quite abstract. Good example is, for example, imagine there is this active profiles annotation. You can switch profiles in your integration test. Imagine you have one integration test that activates the profile integration test, and the second test activates Munich integration test. Two different profiles. Spring doesn't know what we do with the profile. Like in general, with profiles, you usually activate, deactivate beans, modify parts of your code. It can't know what happens behind the scenes. So when the profile is different between two context requests, there won't be a reuse, because Spring is not yet that smart that it analyzes your code and can understand, okay, even though you change the profile, nothing critically happens. This is one of like the key indicators for a context. There are many more. It checks what context initializer you're adding. Where are the property source locations? So if for one integration test you overwrite, please take a look at this YAML file. And for the other one you overwrite, I have a set of hard-coded 5 values that I want to put inside this application context. Spring will check for many of these things and then build a unique key that identifies this request of a context, put it inside this context configuration, and then if the hash codes for two tests that are running, so the first runs creates this context, the second runs before starting a context, Spring will introspect all of these values. There are much more, and we'll check and build this object. If the hash codes match, we have a cache hit, and you get the application context for free out of the cache. How to identify if there were context restarts? 3 ways. First way is visually. So if you run 2 integration tests inside IntelliJ, for example, the first one takes long and the second one is super fast, you can be sure some context was reused. Whenever you see the Spring Boot logo, a context was started for you. So that's just like a cache miss. Something was wrong there. Version 2, more deterministic. There's a logger you can activate. So if you put this logger to trace, run your entire test suite and check the last log, you can understand, or you get an output, how big was my cache, how many misses, how many hits, and get a first identification how good your team is doing. And the third one, that's something new. That's an open source tool I developed. That's currently in like prototype phase, Spring Test Profiler, that I quickly want to show you. You plug this to your project and activate 2 beans. Everything is in a README, but what you get after running your test suite, you get a nice report in source test in target folder. It has some meta information, how big your cache is, but looking at the time, I want to speed it up. The most important part is you can now uniquely compare different contexts that were created that are part of the cache. So for example, I want to compare context 0, whatever it is, whatever classes were used with context 3. And now I get a visual representation of the configurations that were the same and those that weren't the same and hindered context reusability. And I can even click on, for example, here, active profiles. And then this tool shows me, okay, for this one context, you activated the profile test. For the other profile, you activated test and the integration profile. So yeah, sorry, I can't reuse it. You get here the understanding, okay, in this test class, you're getting this context and this is this context. So this is a quite nice indicator at the beginning, because teams, let's check how our audience is. I'm aware, okay, so most of you are aware, that's cool. For most of the people that I talk to or the developers, it's completely new and they are shocked like what's happening or what Spring provides. And the first thing is understanding. The second one is really getting to know how the cache key is built, because once you understand this and have it at back of your head and write in your tests, you are aware that if you do special things, that might be bad for context reusability. And for those, this tool lets you analyze different things of the context, and you can see here for this one integration test, you only overrode one property, or you configured, and the other thing you went crazy and for whatever reasons overrode other properties, and then can step by step work on it and improve your test suite to reuse most of your context. There's one Endgegner, one final boss. There's one thing that I had at this client where we reduced from 26 to 12. This was this issue. So there was one central abstract integration test class that was inherited by each integration test. And at this central place, someone added @dirties context. That dirties context is an annotation that tells Spring, hey, the context that was started within this integration test was somehow dirtied. Example, you modified global state or whatever you did that hinders the context to be reused, and Spring will see this and then shut down immediately the context and won't put it into the cache. So if you have this annotation at a central place, and somehow, unfortunately, I mean, I tapped also myself various times into this. If you search for issues in your Spring integration test suite, you check Stack Overflow, the AI, usually some of the an accepted answer sometimes says just use this, and then it works. It works, yes, but it hinders like context reusability, because like with dirties context, all your context gets started, stopped. So there's no reusability. And if it's at such a central place, all our tests were started, stopped when it comes to the context. And then removing this after a project that grew in 2-3 years, and every integration test implicitly relying on this, was like, yeah, a lot of work, because then you identified every test, what the flaws of every test. So just for you, be aware of this annotation. Use it really as a last resort. There are some reasons where you might say this is valid, we need it, but if you need it, please not at a central place. Otherwise, your tests won't be that fast as they could be. Okay, some quick outlook in the future. So things are changing a bit with Spring Framework 7. There is a new feature. Those contexts that are cached will be paused. So right now they are running, which brings one pitfall we also had in this project. If they are running, each context acquires some threads. And if you have scheduled tasks or message listeners, they are still active. So if the context is active, and back then we configured only one message queue, you have 5 active contexts, 5 listeners that are eagerly listening to the same queue. They're up and running, and you start a 6th context and put something into the queue. And then you wonder, why is my assertion not green? Where is my message? Someone of the active context eagerly grabbed the message, so you can't be sure that you get the message. You can easily fix this by configuring, for example, one queue per context or do something different. But this will be fixed with Spring Framework 7. So Spring will pause the context. This will pause this message listener's scheduled task, and then you don't have this issue anymore. Oh, most of you are aware of caching context, so avoid dirties context, understand how the cache key is built, and monitor the situation. I also don't advertise to religiously reduce it to one context. So you might say, how much should we optimize for? A single context, 5, 4? It depends. Yeah, in general, only if there's a good reason to go with a different context configuration, go for it. Otherwise, try to align on a central 1 or 2 contexts that are used for all your integration tests if you want to be super fast. Okay. Quickly, the last one, end-to-end testing, the holy grail of confidence. So we saw unit testing, slice testing, and integration testing. Really confidence you only get in production. So you can write as many integration tests if you want, but we had scenarios, we had HTTP clients, for a provider where somehow the entire company reused the same API key, even though it was documented differently, and we run into rate limits, or the provider forgot to update their certificates. So there are things you can't test for with automated tests. So you still lack some confidence if you don't test in production or on your QA system. So if your project allows this brings really the first end-to-end test that runs against a deployed environment, brings really a lot of confidence. We had a project where we had checkout-like environment. We prepare test user, and then regularly there is this canary testing concept. It's like you test in a cron-based setup, like every 15 to 20 minutes, a similar happy path, check the outcome, and then verify your production is running as expected. And then also implicitly testing all the downstream systems that are involved. So that's something at the end, if you follow this North Star, brings you really the last tip of the iceberg, but brings also a lot of more challenges: authentication, user setup, cleanup, flakiness, stability. Yeah, this highly depends then on the project, but if you have something involving the UI, usually Selenium, Selenite, Cypress, Playwright, these are the tools you can use. Really quickly, I know we are late, best practices. Test parallelization, so we saw, okay, we can optimize with context caching, but we can go even further. We can parallelize our tests. Easier said than done. We have to make sure that our tests don't depend on the order, there's no shared or mutated state. And if that's the case, we have two ways to parallelize with Java, and this is only focusing Maven, but I'm sure Gradle works similar. We can tell Surefire or failsafe to fork JVMs. So this will really start new Java virtual machines, and then only a subset is passed to the virtual machines. So you get really resource-like isolation of your test suite. The other thing is JUnit-based, thread-based parallelization. There you are within a single JVM and then launch a thread pool to then highly parallelize. For example, usually good for unit testing at the beginning. Parallelize on my classes, but run the methods in sequence, or run everything in parallel, methods and classes. Yeah, you are there. You can fine tune and play around if your project allows. AI, only quickly. I'm playing also quite a lot around with Cloud Code. I heard that Adam Bean showed some nice tricks last week. What I'm doing with my Claude Markdown, it's just so that if you've seen, I'm instructing Claude to be a TDD developer. So I'm telling him to please write your feature first with a failing test, and then show me the test, and then we can argue if this is good. And then you continue or I continue. So you can also do ping pong. So you can say AI writes test, human writes implementation, human writes test, AI writes implementation. So you can switch this. This is just an example that code will be shared in slides. You can try it out. You can get quite far with this. And I guess Adam showed you how to modify the Claude file. That's a cool way I found watching another speaker's talk. So at least better than just telling the AI implement me feature XYZ. This way you iteratively get things done. One reinforcement learning tool I found that is also quite cool, Diff Blue Cover. It's from Oxford University startup, 2-3 years old now. They do reinforcement learning. They have a CLI and also a Spring, an IntelliJ plugin where you can request the AI to write code, but as it's reinforcement learning and not an LLM, it creates compilable and running unit tests. They focus highly on Java and Spring Boot. The main use case is we are a big bank, have legacy code, 0 tests. Here's our tool, run it overnight, and you have at least a baseline. So if you need something like this, take a look. That's cool. Then mutation testing. I only started recently with it. That's quite cool that you can try to adopt. Pit would be the tool of choice with Java. What mutation testing does, it shows you how good your line coverage really is. So like your code coverage might give you a false sense of security, because there are lazy developers that if they optimize only for code coverage, they might not write meaningful tests. And I've seen developers writing no assertions, just so the branch is executed and we have green pipeline. Yeah, what mutation testing does? Mutation testing modifies your source code, bytecode. So imagine you have on the left side, left top, original code, you have an if with some Boolean logic. And what mutation testing does, it mutates the Boolean logic. So it reverses greater to less than, or and to or it removes entire lines of code, or it hard codes a return value, and then runs your test suite against this mutant of code. And if the test fails, it's good. So your test detected an error in your code. If it succeeds, somehow is fishy in your test, and you could do better with your assertions or with the things you're testing. So that's cool. Then you get at the end a mutation score that you can take a look and have something to optimize for. Only quickly. So last 3 pitfalls. At Spring Boot test obsession, I guess the audience here is quite advanced, I would say, but still I've seen developers that if they read this annotation, they tend to use it everywhere. So they think Spring Boot, okay, I have to use it for all my tests, and then they make crazy shortcuts to get to their destination. Because what they end up, if they want to unit test a service, they use at Spring Boot test and then mock with mock bean or Mockito bean all the surroundings, and they repeat this pattern for all of their tests, and then they end up with like a fruit salad of context configurations, of everything super slow, where a unit test could be sufficient or a slice test could be sufficient. So yeah, be aware that with Spring Boot test, it's great, entire context, but also slow. And if you test something in isolation, yeah, do you really need the entire context or not? Mockito bean, mock bean, mock. Mock bean is a Spring Boot annotation that puts a bean inside the context that is mocked, and then you can use Mockito to stop and verify its behavior. Mock bean is deprecated, I guess Spring Boot 3.4, and Mockito bean is like the successor, so that's like interchangeably can be used. You can update your code. And at mock, this is where the issue usually comes. Developers tend to use at mock than at context tests. At mock is only used for your real unit tests, where you use like in-memory Java objects that need to be mocked. With at mock, you can't put anything mocked into the context. It's like for your unit tests. And yeah, so you have to be sure they all kind of the names are similar, but they work in different places. As a reminder, these are not my rules. So like Mockito is, I would say, easy to learn, hard to master. These are the 4 golden Mockito rules that Mockito put on their website. This is something to keep in mind, that using Mockito too much can lead to unexpected behavior in the mental health of your developers, I would say. So there's something to consider. Last pitfall, JUnit 4, JUnit 5. You have to be aware that these test framework versions can't be used in the same test. So you have to be aware when you copy stuff from the internet or outdated Stack Overflow answers, what JUnit version are you actually copying? Because if you copy something from JUnit 4, but your test setup works with JUnit 5, you don't get the expected behavior. If you know it, it's super clear. But also for me, this happens sometimes. If you have JUnit 4 and 5 on the class path, you are on your import, and your IDE suggests which one to import. You are like vibe coding and import whatever is first, and then somehow you end up getting a test from org.junit with JUnit 4. But you try to use the extension model of JUnit 5, then stuff won't work. So with JUnit Vintage Engine, you can run 4 and 5 next to each other. So one test might be written in 4, even 3, JUnit 3. But within the same test, pick one. So you can't mix it. And this is a simple table, so you understand the basic concepts that changed. So run with or rule API is 4. and was merged into the extension model that you get with JUnit 5. So there you have to be cautious when you copy stuff over from the internet. Lifecycle method changed a bit, and the rest is also different. Last context, last information slide. As summary and outlook, yeah, I would say Spring Boot has great testing support, comes with batteries included. In general, the Java testing ecosystem, I would say, is rich and mature. So there are many cool libraries we couldn't touch today. Email testing with Greenmail, Gatling for performance testing, UI testing. So almost for every niche, there is a nice Java testing library that we can use. Slice testing is there for you to be used whenever you touch, for example, tests for the web layer or for your persistence. The last point I want to mention that I would say Spring Boot team and the ecosystem and community are still bringing new features on a regular basis. So it's not like dead. It's not like feature complete. With every new release, there's also some new cool test feature. One of which, for example, the pausing you saw is newly coming, the as-service connection, which makes container configuration for integration tests super convenient. In general, test containers and Docker support increased over time and got better and better. So there are still also test-wise benefits to bump. If you want to go a step further, once I dumped all my testing knowledge into one big online course. If you are interested or one of your colleagues is starting out, take a look at the Testing Spring Boot Applications Masterclass. I wrote an ebook to explore some niche testing libraries that you can take a look. And I co-authored Stratospheric. If you're working with AWS, we showcase within 450 pages, like from zero to deployed version with the AWS SDK, CDK, all major AWS services, GitHub Actions as a pipeline, tooling, monitoring, logging, CloudWatch, observability, everything. I'm running Spring Boot testing workshops, so today was really like bird's eye view, like a lot of input for some of you if you really want in-house or 2-day more slow introduction to some different topics. Please reach out. Don't leave empty-handed. So next slide, you see a QR code. I'm gifting you, everyone who joins the newsletter gets I have a complimentary ebook that summarizes what I just showed to you with more code examples, explains the configuration for you to be downloaded and used and shared. Also share it with your team. There's nothing to hide here, and with that I wish you joyful testing.
Philipp, stellst du die Folien für uns?
Yeah.
Thank you for the talk. What are the main struggles people having while writing tests? I'll give just some examples. For example, if you write an integration test, sometimes some beans are not loaded, and you have to figure out why it's happening. Or you give us examples with test containers, and with test containers sometimes you have to check what's inside of the database. But because of test containers' nature, you don't have static port assigned, so you have to check through the old Docker containers what's going on inside, and then connect to the database with some tools. Or inside of IntelliJ, I know. Do you have any ideas or any collected experience? What are the main problems in this area? Thanks.
So you mind testing in general with integration tests and beans?
I think.
So I guess what's important to understand, differentiate between slice testing, if you do slice testing, to understand which part of your application is loaded, which beans are included. If you write an integration test with Spring Boot test, there should be everything in the context, or everything should be, Spring tries to instantiate everything. If it can't instantiate something, there's a reason. A property is missing in your YAML file. I don't know, more things, or a condition is not met. So the main issue I see developers at the beginning struggle with is getting behind the auto configuration, understanding what auto configuration is, and then applying this from writing code to testing So if you're completely new to Spring Boot, I see developers struggle with this concept because they say it's magic, and then with their tests they say it's also magic. I don't know what happens, but if you step behind the curtain and then understand auto configuration, it's a set of convenient defaults, check the auto configuration classes, that helps.
So is the problem that something is loaded or not loaded? It's hard to determine which bins are not loaded because of not included or some properties. Why it's happening? Okay.
Yeah. I'm not sure. Are you from JetBrains?
Yeah.
I can see the question. Because what I wanted to show you is the nice Spring Debugger.
Yeah.
That's what I use. So Spring Debugger is a super nice plugin that comes with IntelliJ that you have to download.
One more insight, I'm the author.
You are the author.
Yeah.
I was working today in your office next to Marco Bela.
Oh, okay.
I was the entire day in the office. Yeah, cool. Because there's one cool feature I really love. I got in Swiss the question if the Spring Debugger could help me with context caching.
Yep.
If somehow the context caching could be integrated into the debugger, like with my profiler, not the profiler itself, but the idea to get to know. I know that with the debugger, I mean, we can. The examples are too simple to show, but with Spring Debugger, if you debug inside an integration test and let it run, it auto configures the data source for you in your database panel. So this lets you then. Otherwise, you what I did in the past, what he described, I checked ephemeral port 30,720 and the next one 722, and then overwrote my properties. But here it's appearing then out of the box, which is super nice. Yeah, so I would say context configuration, missing beans, then context caching. This would be a cool thing to add. Understanding sometimes the Spring errors, but you can't change that. The Spring
I'll say there are two reasons that something is not loaded: is some property configuration or some auto configuration because of some conditionals.
It's not triggered. Yeah.
But usually this is like the projects I've seen that struggle with this have vastly different test contexts as opposed to their production code, and then hot patching every test is like trying to fix the symptom, but the underlying problem is that maybe out of lack of knowledge or whatever, the test code is vastly different than production code. For example, when and this is then maybe an architectural problem, like you don't pass in a base URL to an HTTP client, so there's no way to sort of mock to stop out the endpoint, and then the problems pile up, and then you're in this rabbit hole where essentially you're completely fucked.
Yeah, that's good. That's good summary. Yeah, but try out the Spring Debugger. I do some advertisement for you. Super nice tool. Give feedback.
But it only works with Spring Boot, right? It doesn't work with Spring Framework projects.
Basically, it can be used. It can be used with plain Spring, but of course, because of missing properties in Spring itself, you won't have part of the features. But still, we will show you like the loaded beans and stuff.
What a coincidence!
It's not a coincidence.
There was another question. Was it answered? I mean,
yeah. Thanks.
We can also do some more detailed discussions. Yeah.
Yeah. Also, question related to caching of context.
Yeah.
You mentioned several times that mock bean, spy bean, and stuff related is duplicated. And mainly in documentation is written just use Makito bin instead. But as far as I know, it's tightly related to caching, and the old annotations don't work properly with caching mechanics. You know how it's implemented? Maybe some overview, some maybe details you deep dive experience. Why this recommendation actually applies?
I haven't dived deeper because I must say most of my projects currently are not using it. You mean with Mockito Bean, caching becomes more, or these are, because with Mock Bean, so to understand, like if you use Mock Bean, this is also it's pointing you in a direction, you're using a different context setup, because if you have context A that mocks 3 beans and context B mocks 0 beans, it can't reuse the context between these test classes, because if mocking, I guess also spying, if you spy on beans, then it's harmful for context caching. But you mentioned like with Mockito Bean, it's
just the name thing, like it's functionally the same.
But there's something with caching, you mean? I would have to look it up. It would be great. I have seen a proposal of someone that did some technical things, mocking, where he tries to overrule Spring and even though something is mocked, replace it. Something weird, but this was not Spring context for sure. I have to pass, I don't know. But at least, so my recommendation is, so depending on what you're doing, like if you want the entire application context, you want the entire, there might be reasons at some tests that you mock some beans, but use this sparingly, not like this integration test now mocked this filter, but here I want this interceptor to be mocked. I would say this is rather a flaw. I mean, if you then test your filters or interceptors, you can also, this is nicely integrated with WebMVC test. So with WebMVC test, you can also test your filters and interceptors. You don't need an entire integration test to toggle on feature 1 and then toggle off feature 2 and to bloat your context configurations. Let's check. You can still submit questions in the Menti if you want. No questions entered. Make sure if you want to take part in the raffle. So one of the resources, 3 of the resources you saw here can be won at your. I guess I'm asking for your favorite niche testing library, your saddest or funniest testing story, and if you have any questions. So would be happy to read them if you can share them. And if you want to take part in the raffle, please add your first name so I can identify you. Other than that, any questions? Yeah?
Regarding the test containers with the database, if you have a database and then you have 24 tests that use the database, you have to clean up between the tests.
Yeah.
Is there any way you would recommend doing that?
So there are 2 ways to do it, depending on how you write your integration test. So if you would do this with Spring Boot test, entire context, and mock MVC, you can use add transactional. As I didn't mention here, when you use add transactional for your Spring tests, by default, Spring will roll back the transaction by default after the test method. So Spring won't commit your change to the database, so nothing won't end up in the database. This is only possible if you're again in the same thread like the context and the test. This is not possible if you do this. If you arrive from the outside with HTTP, you can't use add transactional on your method because it's a different scope.
So if you have any interesting transactional behavior, it's probably also not working.
Yeah, what I do in these cases, so I mean, you can for sure have, the most advanced thing is you write your own extension, cleanup extension, if you want everything to be cleaned up, and then you truncate the tables. You iterate over a list of tables and you use JDBC, that would be like brute force, but you truncate over your tables and then you remove everything.
I've seen that.
You don't want to do that, or?
It was very involved because then you have the order of tables. You can't delete them in any order. And you always have to think about it.
That's true. But if you use cascade the way it should be, and you cascade a delete potentially to all your, which might never be the case. Yes, it should be cascaded. Sure, then somewhere needs to be some implicit logic. Otherwise, you can for sure tell test containers, give me a new database each test. I mean, this is, I would say, too expensive timing-wise, or Yeah, this is what I've seen, what I've done. You can use the repositories, call it delete all. Yeah, but if your database grows, your entity graph grows, yeah, it gets complicated. Yeah.
What you can do, you can customize your test context with a custom test context listener that does this. Then they don't. Can you make your own meta annotation?
That's a nice idea.
Incorporates this.
Yeah.
I've just looked it up. We have this in a project that purges a queue, for example.
Yeah.
Because if you have like lingering messages on a queue, that makes it less flaky.
Yeah.
And then you make your own meta annotation, and that takes care of it.
That's nice. Yeah. But a queue is simpler than a complex entity graph. Good question. Thank you. Next question. I guess behind there was one. Yeah.
I have also a question.
Sure.
So I understand the importance from tester as developer, but how can I explain to someone that it's not a developer?
Management. Oh, yeah.
Yes.
Okay.
For example.
Okay. Yeah, that's a tough question. I mean, I would say a serious engineer takes their work serious, and if you own the code that you check in, you should also own the responsibility. I at least have worked in a scenario where we had on-call and really you build, you run it. So I worked for like IT company where I was like also on-call one day and then went to the cinema and then got the call and had to step out. So, and these occurrences let you like really show the importance of testing, because I mean, not only with testing it could be solved. I mean, downstream system down, there's many reasons. But if you go that way, and I see the industry going towards it, not handing over something to operations, so it's really like you own what you produce and you're careful crafting, then I would say it takes a good tech lead to argue it. I mean, if management still says we don't want any tests, let them experience it the hard way. Then after 1 year of project work, the new developers will say, hey, we can't do anything here because we can't refactor, we have no confidence. Lucky you, we were first in the market, but now we are the slowest to adopt to regulation changes. I don't know, this depends on the domain, but that's how I do it, yeah.
Okay, thank you, Philip, for coming here.
Welcome.